Hey everyone, I'm back with another problem on the InterviewBit series on the topic arrays. So the problem today is add 1 to a number. So we are given a number which is represented as an array of digits and we need to add the digit 1 to this number. Okay. So the problem constraints are the length of the array or the length of the digits array is less than or equal to 10 to the power 6 and the digits can vary from 0 to 9. Right, so let's just move on. Let's consider a test case. Let's take 129. The number is 129. Right, now I know that if we add 129 plus 1, I'll get 130. But how do you do it here? So I cannot, so to make things easier for me, what I'll try to do is I'll first reverse this array. Why will I reverse this array? Because when I add something to a number, I do it from the zeroth place, right? But in order to get this done, I need to reverse it. If I need to start from the very start, okay, so I need to reverse it. So reverse the number to make it easier for me, right? Now we need to add one. How do I add one to this number? So the first thing is I'll iterate through all the digits. So the first digit is 9, right? And in the first digit, we need to add for the first digit, we'll add a of I plus 1, right? For the first digit, we need to add 1 to this. So the sum here would be equal to a of I plus 1. Okay, so what will we get? So the sum here would be equals to 10. Right, but you cannot store 10 in a as a single digit, right? You need to store 0. Okay, so what will we do is we'll store 0 here. So what about 1? 1 will be carry forwarded, so we need to also maintain a variable called carry. Okay, so initially it was 0, now the carry becomes 1 after this digit. So now let's move on to the next element, right? So now we have 2, and for every other case, so for first digit the case would be this. For every other digit, what we will do is the sum would be equals to a of I plus carry. The sum would be equals to a of I plus carry. So here 2 plus carry is 1, so it becomes 3, right? So the sum now is 3. Now we need to check. So what is 3? 3 is a single digit, so we can store it in that place only, right? So we'll store 3 and the carry becomes 0 here, right? Now let's move on to the next element, which is 1. Now for 1, we'll do sum is equals to a of I plus carry. The carry was 0, so it becomes 1 again, right? Perfect. And at last, I'm going to reverse this array completely to get my final answer, which is 130. So this is how you add 1 to a number, right? Let's take another test case, which is 099. So in this case, we have the first digit as a 0. But is it needed? Is it needed? Is 0, it is same as writing 099. So can I write it as 99 only? Right. So one more important thing before approaching this would be to always remove the initial zeros we have in the array, right? So my array would start from the first non-zero element, which is 9 and 9. So first pre-processing would be this, right? So the first pre-processing step would be to remove the initial zeros, right? And the next step would be to reverse the array to make it easier for me to add one. If you reverse 99, it would remain 99 only, right? Perfect. So now let's add 1 to this number, right? So for the first digit, I'll have sum is equals to 0, carry is equals to 0. For the first digit, we need to actually add 1 to it, right? What I'll do is 9 plus 10, 9 plus 1, so it becomes 10. The sum becomes 10. And you'll store 0 here, right? You'll store 0 here and make the carry 1 and move it forward. Now the 9, there is another 9, so we add the carry with this 9, so it becomes 10 again. So the sum becomes 10 again. We make the carry 1 again, store 0 and move forward, but there is no other element after this, so this was the end. So do we need to stop here? No, we cannot. There is a carry left over, right? So we need to always check at the end of the iteration whether carry is empty or not. If there is a carry, then we need to push it to our answer, right? But initially it was 0 0. We also need to push carry if it is non-zero, right? So it becomes 0 0 1, and finally you can reverse it to get 1 0 0, which is our final answer, right? So this is how you approach this problem. Simple iteration, just you need to carry the sum, and you need to also maintain a variable called carry and move it forward. There were some edge cases like pre-processing the zeros and all, and also at the end you need to always check whether the carry is empty or not, and as per that value you need to push it back into the answer, right? So what is the time complexity for this solution? So we are only traversing the digits array once, right? So it's linear, so it would be O of n. What is the space complexity? So we are always creating an array called answer for storing, right? Here we created, here we also did. So the space complexity also becomes O of n. It's a linear time, linear space solution. Perfect. I hope you understood the explanation. Let's move on to the coding part. Let's code it up real quick. So we are given an array of digits. So let's first get the size of it. It would be a dot size. So the first thing which I'm going to do is I'll reverse this array. Okay. So it would be easier for me to add from the starting. Okay. Right, now I need to check whether the first few digits were 0 or not, but now I have reversed it. So the first elements are gone to the end. So I need to if I need to check for zeros, I need to start checking from the end. So I can check it like this: while a is not empty and a dot back, this gives me the last element, and till it is 0, then I need to pop those elements because I do not need the zeros at my start, which is currently at the end because I have reversed the array, right? Now there can be one possible edge case that a becomes empty. All the digits were 0, so a becomes empty. So in that case, if a goes empty, so this is a very nice base case here or an edge case here. So if a goes empty and you need to add 1 to an empty number, you'll simply return 1, right? Okay, now let's move on to the current implementation. We'll iterate over all the digits and we'll say sum is equals to a of I plus carry, right? The current sum is going to be a of I plus carry, but remember I told you that for the first digit the sum would be equals to a of I plus carry plus 1, just for the first digit. So if I is equals to 0, sum plus is equals to 1, right? Perfect. Now what we can do is we need to take out the digit which we need to store at this particular index. So I'll say current digit is going to be sum mod 10 and carry is equals to sum divided by 10, right? And simply I can store a of I is equals to current digit, right? I'll also need to maintain a carry variable here, right? Okay, perfect. Now it is done. At the end I need to check if my carry is non-zero, then I need to push my carry to the array. Okay, this would be equals to carry, and finally after doing this I can reverse my current array and I'll just return a. That's it. Let's try to run it and check. The trivial cases are passed. We'll submit it. Yeah, so this is accepted. I hope you guys understood this problem. So this was it for this problem. I'll see you guys in the next video. Till then, take care. Okay, chalo, bye.